Okay, in our last segment we did a lot of talk about memory and the memory managed unit, and so I tried to put a part two together. That first part was getting quite long. So part two, we're going to actually do some assembly language code and work with them registers. So let's take a look at what where we're at and what we're going to do. Okay, we're still going to use the same stuff we had in the last presentation, and we're still going to use these top ones out of the logical registers. We're going to use 38 through 3F, just as we talked about in part one. And again, you've seen this many times in that part one. And what we're really going to be using is these bottom three down here. Okay, the system, 2000 range and the 4000 range, which is the MMU 0, 1, and 2, or blocks 38, 39, and 3A. They're all hex numbers. That's the three we're going to use. Now remember, our 32 character screen is located at hex 400 to 5FF. So the 32 character screen is located down here. And the other thing to remember is our basic programs when I load in was up here at 2601. So just need to remember them two numbers for the time being. Okay, we're going to type a program in. Big heavy duty program, you get to type it in. It does a lot of things there, doesn't it? For I equals 1 to 20, print I, next I. So that's it. It does have a purpose in our test today. What we're going to do with our assembly language program is we're going to store 38 in MMU register FFA1 and A2. So now all three of these address spaces are pointing to, remember, our physical memory. All three will be pointing to the same physical memory block. Our 32 character screen is still in this block at 400. We move up to this block here, our address range in our program will be at 2400. And we move up to this one, it will be at 4400, where that 32 character screen is actually located. Not actually, it's located in the physical, in the block. Here's another way to look at it. The physical address is at 70,000 hex. We're having all three of these address spaces pointing to the physical space. So if I change something here, it shows up over in here. If I change something here, it shows up in there, etc. So again, our low res text screen is at 400 in here, 2400 here, 4400 in here. So let's take a look at the code we're going to do today. Let me switch screens here, if I may. Find out, there it is. Okay, here's our program for today. It's very short. You can type it in pretty easily. You could use that common.include file we had. The only thing we'd be using out of it is this one line here, column 32, because we're going to make sure we switch to a 32 character screen in our test. And here's all the MM registers. I just put them in here. The only two we're going to work with is MM1 and MM2, them two address spaces. Okay, what we're going to put on the screen, okay, is the screen point A. We're going to put that in at 4EE hex, okay? That's kind of the middle of the 32 character screen. And point B is going to be at wherever screen point A is, plus 2000 plus 32. It's a 32 character screen, so we're going to go down one line. Point C starts where B is, add another 2000 to it, and go down one more line, 32. So let's see what that, when it all assembles, that's what it looks like. The first screen address is 4 easy easy. The second one is 250 easy. And the third one is 45 too easy. Now remember, that's our address basis with 0,000s, 2,000s, and 4,000. So that's what we're going to put on the screen. Here's our program. We're going to arg at 1000, so the program comes in hex 1000. We'll do a jump. We'll do a jump subroutine to put it in 32 character mode, so we've got the correct screen up there. We're going to load up our block number, which is 38, excuse me, which was our system block. We'll store it in MM1 and MM2. Now we've got all three address spaces pointing to the same location. Now here's our program. Again, this is not heavy-duty program. It's good for example exercise. Once you type this in, you can change it a lot and do a lot of things with this one. We're going to loop, make a quick loop here. We're going to load 3 in register B. We're going to load a character A in register A. And we're going to load our register X where we want to put on the screen. We're going to use the screen point A. That's on the low-res screen that we looked at earlier. Here's a loop we're going to do. Now we're going to store whatever in register A, which happens to be an A, into X. It's going to go on a 32 character screen and bump register X by 1. Decrement B, so B is going to go from 3 to 2. It's not equal to 0, loop again. So we'll go through there 3 times. We'll put 3 A's side by side on the screen. Drop down here, we're going to put a 3 in B again. We'll put the letter B in register A, and we'll start it, this time we're going to start at point B, and we'll loop through here 3 times to put 3 B's on the screen. Likewise, we're going to come down here and do the same thing with point C. We're going to put a C on the screen, loop through there 3 times. We'll load up 39, which is our block number. We'll restore it back to what it was when we started. We'll load up 3A, restore our block number, and go back to basic. Okay, that's all the code. You can type this very short. You can type that in and make some modifications to it and print on different places on the screen. Remember, the screen location is the starting one that you would want to use up here is in between 400 hex and 5 FFF hex. That's the range you can do stuff in the screen. So back to here, catch up with the screens. Got one more thing we can, well, no, before we do that, we need to actually see if our code works. I went to the wrong screen. Okay, here we are. I've already typed the program, the basic program in, and did a load in on our code. So here's our basic program. And the reason the basic program is to show that that address space at FFA1, remember that was the 2000 space, at 2600 we loaded a program. We're not going to touch that. We're going to address the screen by changing the block number. We'll come back, our basic program should still be there. So we can run this. Again, not very exciting, but we have a basic program in memory and it works. I've also loaded in the assembly language program, and we will execute that, and there's our results. Remember, 3 different lines, 3 different address spaces. We addressed it at 0400s, the 2400s, and the 4400 range, and we printed out three lines on the screen. There in that momentary, we had not pointed to the basic program, but we can run it and it's still there. We can execute the program, it's still there. So hope you get some idea of what you can do with using different MMU blocks by having stuff off screen, on screen, out of memory, in memory, move stuff around. You can have a lot more loaded in to use with your program and be off in a different block and bring it in whenever you need it. Very, very, very helpful. That's what the use of the 512K is for. Okay, one more thing. I need to go back here. And okay, one more thing on this here. Remember, we were at our systems down here at logical space 0 to 1 FFF, block 38, register 0, and this is the physical space is 7,000 hex. That's the numbers we never really talked about. Okay, but that's where all the stuff, the real stuff happens that the gimme chip can say, okay, I'm going to display it on the screen because it's actually physically there. Now if I can go back to here, and we'll do one more thing. Bear with me, I gotta type this in. In your Color Computer 3, in your programming guide, there's two instructions, or two things now you probably never use. There's an L peek and an L poke. And they was for poking for very big high addresses. So 704EE. Remember, that was our address that we used in the our program, was at 4EE. Okay, this is the actual real physical address, and we'll put a 65 in there, which 65 is a capital letter A, and we'll poke that in, and magically it just showed up on the screen. Okay, so that was back going right to the physical screen, not going through the logical address space. I hope that doesn't confuse, but it's just show you what, try to correlate the physical and the logical spaces, what they are. So I don't know if I've made it more confusing. Hope not. The programs, go back through this here and stop it and type the program in, give it a try putting different stuff on the screen in different areas and stuff like that, and experiment with it and get used to what the MMU registers really do. So with that, see you next time.